Welcome you all. In previous class, two class we completed on this one. The first class is in that one we covered introduction of geotechnical engineering. What is geotechnical engineering? And in that one we studied names of geotechnical divisions of geotechnical engineering: soil mechanics, soil engineering, rock mechanics, rock engineering, foundation engineering, geology, a part of geology and all. And then the second that video we studied about scope of geotechnical engineering, where all this concept will be used. And in the third, in the second video only, in the second part we studied origin of soil, how soil originates. Okay, the soil originates because of weathering of rock, and rock weathering can happen in two forms. That the first one is the mechanical weathering and the second one is the chemical weathering. And how mechanical weathering, that is a physical weathering, how exactly it happens, that we study. How chemical weathering happens, that also we study. Now we are entering into three-phase system in soil. Now my dear students, now onwards whatever I am going to teach, this is considered as soil mechanics. From this third video, whatever we are studying, this is called as soil mechanics. And soil mechanics is very important concept or subject. Okay now, and you need to understand it from the sense of first class to there. Okay, and if you have any doubts, any difficulty in understanding, you can ask at any time. Okay now we will go it in depth about soil mechanics. See here, the soil, whatever you are seeing here, okay, now whatever you are seeing here, this is a soil. It looks in general form. See here some particles are there. Some particles are there. In between some black color is there, means here some other chemicals may be there, or it might be again particle. Or the color, this is a white and black, therefore it's like that. It might be a water also. It might be water also. And here some blank is there. Here some white color. Here nothing is there. I can say that nothing is there, means there might be a air here. And this is a solids. This is a solids. Okay, means when you hold a particular some amount of soil in your hand. See, this is your hand, and when you bring some soil from a field, then this soil will consist of particles, and this soil will consist of water also, and this soils may have some voids inside also. Okay now, therefore soil means it's not only the particles. Soil means all together, all these together, that water, that air, solids and water, all three that makes a soil as a soil. Understood? Therefore we will call it as a three-phase system in soil. Okay, in soil we have a three phases. That in middle school and all, you studied three phases of material: solids, liquids and gases. And like that only in the soil also we will have a solids, we will have a liquid as a water, and we will have gas, that is the air, we will have inside it. Okay, but the studying, for the study purpose, how much volume is there, how much volume of solids are there, how much volume of air is there, how much volume of water is there, this is very difficult when you bring the soil randomly. But we need to deal with like that only, because the practical problems will be very difficult. But for the study purpose, what we are doing is, we will divide this soil, we will separate all solid particles and we will keep it below. We will keep it below. This we will call it as a solid particles, and separate all the water particles and put it in this box. Okay, this we will call it as a water. This is the water phase. And separate all the air and put it here. This is the air phase. Okay, means a soil, when I hold it, it will be a mixture of all randomly, but for the study purpose, solids is this, and this is the water, and this is the air. Now this soil can be dealt with respect to two parameters. The one is the volumetric and second one is the weight. For example, I say that I got one truck of soil. What is the meaning of one truck of soil? Okay, this is a truck and I got one truck of soil. What is the meaning of this one? The meaning you can express it in two different ways. You can say that it is a 6 meter cube of soil. This is a 6 meter cube of soil, means you are expressing soil in terms of volume. And even you can say that it is about 10 tons of soil. You can say that it is the 10 ton of soil. See, you are expressing it with respect to weight. Means this soil, whenever you deal in geotechnical engineering, you can express them in terms of volume or in terms of weight. Therefore, these three phases also I will give us some names. That is this much. If I measure this solids in terms of volume, I will call it as a VS, that is a volume of solids. This is volume of solids, and this term I will call it as a volume of water, and this is volume of air. Like that, if I measure this one with respect to weight, this is the volume weight of solids and weight of water and weight of air. Okay, now then here this solids is there. No, this is a never changing volume. Its weight and volume are constant, because unless and until you put separately that you add or delete. Okay, you add or remove solid particles, unless and until then, because of any actions, the weight will not reduce. The solids weight 1 kg, in that one if 600 grams of solids are there, then 600 will be remain same. In winter, in summer, in that year, this year, last 10 years, after 10 years also, that 600 gram of solid means 600 gram of solid only. The particles may be splitted or combined, or it may be integrated or disintegrated, but that doesn't matter. The weight will be 600 gram means 600 gram only, or whatever the volume you mentioned, that volume will be same. Therefore, solids volume and solids weight is always constant. Then when you come to this part, this is the volume of air and volume of water. This will be a variable. In a rainy season, the entire this box may be filled by water. In a summer season, the entire water may be evaporated and this entire box may be completely filled by air also. Therefore, this part other than solids, whatever you observe, that we will call it as a voids in the soil. Now that volume we will represent it as a volume of voids. That we will call it as a volume of voids. If you measure volume of voids in terms of weight, then we will call it as a weight of voids. But unfortunately, we don't have a weight for air, or otherwise if it is there, but that is a very small and we can neglect it. Therefore, weight of air is considered as a 0. Then weight of voids will be weight of water. Okay, now this is all about three-phase system in soil. Now, as I said, these two conditions also we can observe. That is, this we may observe in summer. This we may observe in rainy season. This soil not only in summer, after oven dry also, you put a soil into the oven and bring it out, then you can see this phases. And rainy season, not only in rainy season, but underground, for example, marine soil, water level is here and soil is here. This soil can be said denoted with this diagram. Here what it is there here is the solids are there and the entire void is filled by air. And here the entire void is filled by water. Therefore, this soil condition we will call it as a dry state of soil. This state we will call it as a dry state of soil, and this we will call it as a saturated state of soil. Okay, now this is a dry state and this is the saturated state. Then what about the previous one? Here all three are there. Here the solids are there, water is there and air is there. We will call it as a bulk stage of soil, or bulk soil, or even you can call it as a sometimes we can call it as a partially saturated soil. Okay, now these terms you can note down. Now you came to know that what is the meaning of dry state of soil and what is the meaning of saturated state of soil. Now in this diagram we will derive some equations, some terms. That first term we will call it as a volume relations. In that volume relation, the first term is a voids ratio. You already know this was a soil and this is a solids and this is a water and this is the air. Okay. Now I am comparing how much of voids are there, how much solids are there and how much voids are there. I am comparing these voids with respect to solids. Then I can call that comparison, I can call it as a voids ratio and denoted by the term E. This is defined as the ratio of volume of voids to the volume of solids is called as voids ratio. That you can call it as a E is defined as VV divided by VS. This is a ratio. And the void ratio of the soil is always more than 0. Just because we are comparing the top and bottom, how much voids are there in a particular solids with a particular solids, that you are going to consider. Okay. Here one task is given, you can work it out. What will be the voids ratio, voids of a soil mass in which particles are considered as regular spherical with uniform size, kept loosely and kept densely. Uniform size is there but kept loosely, kept densely. That one task is there, you can think over it and find out the voids ratio for the two cases. Now we came to know what the meaning of voids ratio is. What? Voids ratio can be defined as volume of voids to the volume of solids. Here this is not expressed in terms of percentage because this is just a ratio. Okay. And the second term we will define here in this chapter, that is a porosity. That is porosity. This is also known as a percentage of voids. Percentage of voids. This is the ratio of volume of voids to the total volume expressed in percentage. Porosity is denoted by the term N. Okay. N is defined as what? Total volume of voids, how much voids are there with respect to total volume. In earlier definitions we defined how much voids are there with respect to solids, but here how much voids are there with respect to total volume. Therefore the total volume with respect to you are comparing, therefore it can be expressed in terms of percentage also. Therefore this is called as percentage of voids or porosity. The word porosity mainly we will use in agriculture point of view or irrigation point of view. Okay, no? But in geotechnical point of view, percentage of voids is a good word, but sometimes also we will use it voids ratio. But many a cases, we will use it as porosity, and in many cases we don't use N, we will use voids ratio. Voids ratio is a very, very important term for us that we studied in previous slide. Okay, and the third, then what is the relation between voids ratio and porosity? If I know porosity, I could draw voids ratio, I could calculate voids ratio. If I know voids ratio, I could calculate that porosity. Is it possible? That is the question. Yes, it is a possible. Therefore, we will derive an expression between the voids ratio and porosity. It's just easy. Just let us consider a three-phase system, and in that one you can define E equal to VV by Vs and N equal to VV by V. This is a VV by V. Okay. Now this one here, the common term you can see that the numerator you are seeing VV, and here also numerator is VV. Therefore, what we'll do, we will divide it equation 1 by equation 2. Equation 1 by equation 2. If I do E equal to VV by Vs and N equal to VV by V. Now if I divide it entire thing, then the numerator cancels. This denominator come to the top. Therefore E by N equal to V by Vs. This V I can write it in three-phase diagram. You can see here, this is a solids and this is a voids. Therefore the total V I can express as a volume of solids plus volume of voids. That I will write here. That is volume of solids plus volume of voids divided by Vs. Okay, now I will split this one Vs by Vs and Vv by Vs. Therefore, I will get E by N equal to 1 plus Vv by Vs. Then what is this Vv by Vs? Vv by Vs is nothing but again E. Therefore, E divided by N equal to 1 plus E. Then I can express this N, take this side, N equal to what? E divided by 1 plus E. See, I got an expression for N equal to E divided by 1 plus E. Means if I know the White's ratio, I can get a porosity. Okay. The same way, rearrange these terms as I do here, rearrange them. Then what happens? This bring here N into 1 plus E equal to E. Then take N inside, N plus Ne equal to E. Take Ne this side, E minus Ne equal to N. Then take E common, 1 minus N equal to N. Then E equal to 1 minus N divided by N. See, again I got one more expression, that is, if I know N value, I can get E value. If I know E value, I can get N value. Both. Okay, whichever you want, you can consider. This is a relation between the White's ratio and porosity. Okay, then we will study the third term, that is a degree of saturation. We will study the third term, that is a degree of saturation. Degree of saturation means how much of water is there in Whites. See, this is a three-phase diagram. In this three-phase diagram, this is a solids, we know it is unchanged and it is always constant. This is a water and this is the air, and these two together it is called as volume of Whites. But in this volume of Whites, how much water is there? In this volume of Whites, how much water is there? That is Vv by Vw. This can be expressed as Vw by Vv, and S equal to Vw is the degree of saturation. It is the ratio of volume of water to the volume of Whites expressed in percentage. You can multiply 100 to that and you will get a percentage. For the saturated soil, degree of saturation is, just think about this and fill it. For the saturated soil, degree of saturation is what? For saturated soil, it is said, for the saturated soil means only solids are there and water is there. Therefore, here volume of Whites and volume of water both are same. Then volume of Whites and volume of water both are same, then cancels and S equal to 1 or 100%. Means when for saturated soil degree of saturation is 1, or it might be 100%. Okay. For the dry soil, the degree of saturation is what? For dry soil, what happens? Only solids are there and air is there. Then volume of Whites is present, volume of Vv is there, but Vw, volume of water, is not there. Therefore, 0 and Vv, therefore S equal to 0. Therefore, for dry state of soil, this will be 0 or 0%. This is degree of saturation. Next, the fourth term comes the air content. The air content is denoted as AC. In this air content, it is just an opposite or a complementary to your degree of saturation. In the last term, we studied in an entire volume of Whites and entire volume of Whites how much water was there, that we studied in the previous slide. But now, how much air is there in this entire Whites? In the entire Whites, how much air is there? Okay, that is your ratio of Va to the Vv. You can express in terms of 100, in terms of percentage. Okay, therefore the air content is defined as the volume of air Whites to the volume of total Whites. Okay, that you can express in terms of percentage. Now, what is the relation between degree of saturation and air content? Just it is a very easy. Yes, we defined it as a Vw divided by Vv, and AC, air content, we defined it as a Va divided by Vv. Now you can see the denominators are same. Don't divide it by. Just I will add them. What happens, we'll see. S plus AC, if I add, then Vw divided by Vv plus Va divided by Vv. Then now see, the denominators are same, therefore numerator can be added, then VW plus VA divided by VV. Just observe this equation very carefully, you will get something very interesting, that this is a solids and this is a volume of water and this is the volume of air, and volume of air plus volume of water is nothing but volume of whites. Therefore volume of air plus volume of water, I can write it as a volume of whites, and denominator is volume of whites, cancels and equal to 1. Therefore S plus AC equal to 1 is the answer. This is the relation between degree of saturation and air content. And the last term we have in this volume relations, that is a percentage of air whites. Percentage of air whites is expressed in terms of with the term that is a Na, and here I am comparing what I am comparing. This is a solids, this is a water, and this is the air. I am comparing how much amount of air is there to the entire volume. How much of air is there to the entire volume, that I am going to compare. That is the ratio of VA to the V is expressed in terms of percentage. Okay, now this is the percentage of air whites. Next, coming to the relation between percentage of air whites Na, porosity N, and AC, air content AC. Okay, now we want the relation between all these three. First we will write what is the meaning of them. That is a Na equal to Va divided by V, and N equal to Vv divided by V, and AC equal to Vv divided by Va divided by Vv. Now looking at this, the denominator is Vv and the numerator is Vv. Therefore if I multiply, I will get something interesting, right? N into AC equal to what? Vv divided by V into Va divided by Vv. This Vv cancels and I will get Va divided by V. This is nothing but N into AC. Now with this Va by V, we can see here, that is your Na. Therefore N into AC equal to Na is your answer. The relation between percentage of air whites, porosity and air content is N into AC equal to Na. Okay, now till now we studied volume relations. In volumes, volume of whites, volume of water, volume of solids, and in that one volume of air is also there, and volume of whites we defined, total volume we defined, and after that 5 terms we defined. The one is a whites ratio, 5 terms we defined. The one is a whites ratio, porosity, degree of saturation, and air content, and percentage air whites. These 5 terms we defined, and we got an interrelation between E and N, interrelation between S and AC, and interrelation between Na and N and AC. Okay, these 3 interrelations and 5 terms we defined till now. We will complete our lecture to this now, and in the next class we will go ahead. Okay, now thank you very much. If you have any doubts, you can ask. Okay, and don't think that in the geotechnical engineering full of problems or full of derivations are there. Not like that, but in a soil mechanics, because we are applying mechanics concept, mechanics is also again a problematic, and therefore we are understanding the soil. And the practical aspects, when you go to the field, when you go in front of the soil, how to deal with that soil and volume and all, that we will explain later after the all derivations. When it completes, I will explain the practical aspects of soil mechanics. Okay, till then, bye bye, take care.